Okay. Hello, my name is Makoto, and this is a talk for ENS. Thank you for coming. And I just did, raise hands ENS name, and I think more than half the people have ENS name. So I'll omit what ENS is. This is usually the first slide said, there's a hexadecimal, and this is my token.is, so send me ETH. That's how I start, but I will skip all that. And yeah, so we've been doing for almost 4 years. We just had a 4 years anniversary, and since then we have about almost like 300,000 names, and we have over like 100,000 users. And more importantly, this is the hardest part, but we have over 250 Dapps wallet and the exchanges which integrates with ENS. And the ENS is very simple smart contract, and its utility only like multiplies when more Dapps and the wallets integrate. So if you are the builder, or if you are working on any of the crypto project, make sure your ENS is supported. Thank you. And we are one of the oldest smart contract. As I mentioned at the start of the talk, it first launched May the 4th, May the 4th be with you, so everybody can remember, 2017. And it's been very kind of stagnant, people using, but when the kind of last bull market and there's an NFT craze, ENS is NFT, and one of the easiest things, people can say your friends or acquaintance said, hey, I want to do crypto, what can I do first thing? Getting ENS name is one of the first things you could do. So it's one of the most affordable things you can do before people go, ape into DeFi, that kind of crazy stuff. This is the easiest thing. So, and it's growing fast. This is a chart from the Etherscan that according to they recently integrate reverse record into their platform, so that now if you look at your transaction history, you can actually see if the sender or receiver has ENS name resolved using reverse record, you can actually see who's sending to who, which enhances the usage. And I'm glad it's starting from Abe in his first day's talk. He was talking ENS left and right, and almost you can use ENS as a kind of your on-chain reputation identity. So I'm very pleased that it's kind of adoption is happening. But especially this last 1 month, you can see hockey stick curve. But there is a kind of gotcha that until April, May, as you probably know, gas price was really, really high. So at a certain point, until DeFi summer starts, it was less than, to register ENS name, you only pay $5 a year. And the gas cost used to be a couple of dollars. But during the DeFi summer, at the highest, people have to pay $150 just to register a name. That was ridiculous. But amazingly, still about 100 people a day are registering. So I was quite amazed. But then, I think during the May, when we hit down from the all-time high and everybody gets slashed and liquidated, that's the opportunity for ENS lover that yes, I can buy more ENS names. So that's when gas price went down, ENS name went to the moon. So I hope gas price stays low and people can start using. But we can't just rely on Ethereum gas price happen to be cheap. So we have to do something. So this is the main focus of my talk today. Let me just check time. So today's agenda is, this is a relatively technical talk. I have some slide, but I don't expect you to understand the whole line by line. There's actually YouTube videos and stuff. So if you are interested, I'll publish the slides so you can actually watch the YouTube video 3-5 times until you understand. But this is just try to understand the gist of what we're trying to do. And also this is still kind of open-ended. We have some prototypes, but the implementation could change based on your input or feedback. So if you are layer 2 operator, developer, or Dapps who's thinking about using, issuing subdomain to your user or something, just talk to me so we can discuss. And depending on whatever chain of your favorite, we'll try to think about it. Okay, so we're going to talk about 4 topics. First, the ENS layer 2 design consideration. We have very unique kind of sets of things we had to think as opposed to any other people doing this kind of layer 2 sidechain, friends, enemy integration. And also we do have one step ahead on the, oh yeah, we have some idea called rollup agnostic L2 integration. So this is where a bit of codes come in, but again, don't focus too much on the coding logic because I don't fully understand the full logic yet, so I'm same with you guys. And also then number 3 is something we've been discussing for last, especially a couple of few months when like our market dynamic quite changed that like, you can't just support L2 rollups and just get it done. So we were just trying to think about how we can accommodate these. And if I have time, I'll thought about like there's some FAQ I came up so I can answer and we might have time for FAQ. Okay. So yeah, L2 design consideration. So majority of most kind of L2 EVM chain strategy is like a step 1, copy your own code, or you might want to copy someone else's code if the license permits, and you just deploy to your favorite chain, and you ask your user to change the network. So this is a case of the I think this is Sushi Swap that like hey, this is kind of interesting. Like a couple of years ago, this was similar UI of like hey, you want access to the Dapps, which wallet you want to use, and you had like a MetaMask and all sorts of 5-10 different wallets, and the people get confused which one to connect to. Now we have new problem of like which network to connect to. Should I go to Polygon, Phantom, BSC, XDAI, and then now there's a rollup, Arbitrum, also Optimism, Arbitrum, and we have ELMES, which everybody got their money. What was the trust community stuff? Yeah, you earning lots of money. I think after the talk, you guys should change each other. But like you guys are already experiencing L2, right? But like asking, this is quite problematic for ENS. Well, not just for any DeFi that like it's a before, even when people are using, people have many different ways to interact with Ethereum. And yes, MetaMask is a kind of dominant usage, but there's lots of wallets, and all wallets, especially like, if you are on the conference, you're going to use mobile wallet. Some people might use like MetaMask mobile, but some people might use like, I don't know, Trust Wallet, Alpha Wallet, that kind of stuff. And they all have to keep up with all the, how to switch to the different network, which is very, very hard. So this is kind of things we have to think about it. But like, I think most other DeFi apps, like you just like select network, and if you want to drive traffic, you just mean like a drop Matic or drop like Sushi, so that hope like people goes to this network. So this is a usual approach. But I already mentioned some of them. But like yeah, so the biggest. Let me just go this one first. So no switch network. In case of ENS, ENS is everywhere. ENS is in MetaMask. ENS is in Etherscan. ENS is in OpenSea. And if we ask people to use ENS for certain network, you have to depend on all the underlying Dapps to integrate to make sure they integrate with the specific network. But that's very hard to have everybody have the support for specific chain. So we don't want that. That's kind of big part, because unlike DeFi, which is like as long as you make money, doesn't really matter what the word is. In our case, you want to be accessible. If you tell me what's your ETH address, I want to say matokun.eth, and no matter what network you are interested, you still want to get your ETH address back. So this is a fundamental difference of the design consideration, which is different from any other DeFi. And I think this is kind of similar to any other people that like, there's so many things happening, right? This year is a year of like scaling, right? There's optimism when it's Arbitrum, everything. And we don't know which one's going to win yet. And also we want to be the public kind of service for entire Ethereum ecosystem. And eventually we might have to pick on some network, but at this moment, it's too early to just use ENS, only you do this. We try to avoid that as much as possible. And another thing is, so minimize additional trust assumption. Let me go back to this slide. Initially, we first started the design discussion when Vitalik posted a blog said, I think it was in a post in the East Research or this magician, that he posted that something titled a general purpose L2 friendly ENS standard. And I think in this context, he was saying like rollup is here to stay. Rollup should remain even L2 comes, ETH2 comes in. So we have to design where rollup is everywhere. And at that point, he actually suggested to have some sort of like a bonding mechanism that like if you want to resolve ENS name in a specific chain, you should have some sort of bonding to attest that this name, which is resolving in L2, is correct. And if it's wrong, it is slash or something. That was kind of his initial suggestion. Then after that, we had about 2-3 meetings with various like L2 operators. Like we got, I think we got lots of input from especially Arbitrum team. That when we are talking about, thing is like I think Harry Calodona, I don't know how to spell, but from Arbitrum, he said like, well, if it's L2 or rollup, there's a ways to, you don't have to have your own like a ENS name validation network to attest, because L2 already has a ways to verify the state of the data of L2 in L1. You know, like rollup and the L2 relies security of L2 into L1. So you have the basic mechanism. So why don't we incorporate that? That was kind of suggestion came from the Harry, and basically the discussion with Nick Johnson, who's the founder of the ENS, and Harry from the CTO of the Arbitrum. So that kind of steers our design. And then we came up with kind of design I'm going to explain later. But through this discussion, so one thing we said, like we don't want to keep adding additional trust assumption. So if you are going to use specific L2, you are fine to trust that L2, but you don't want to keep adding new things. So that's kind of design principle. Some of the solution, it works. Some of them doesn't, but I'll explain later. Okay, so rollup agnostic L2 integration. So far, it's okay? Good? Yeah, okay, good. So before I talk about specific implementation, so this is where it gets a bit more technical. How many people do like Solidity? Okay, 30%, yeah. Other people, if you can understand, that's great. If it's not, don't worry. So this is a fundamental of the basic structure of ENS. ENS is one of the simplest smart contract. Like the core of the architecture, the model started back in 2017. There's no like known pattern and stuff. And at that time, so we have a base smart contract called ENS registry, which is almost like a proxy pattern which everybody uses nowadays. But without using any delegate call or fallback or anything, it's very simple. The ENS registry is a dictionary of the name of ENS as a key and which value, which returns another smart contract called resolver. And so first, like you say, hey, what's my Ethereum address? You ask ENS registry, and it returns the resolver different smart contract address. And the client asks second call to the resolver, and the resolver has actual logic of what the data is. So even when you are doing like a lookup on the MetaMask, it looks like it's showing the resolving in one name. Underneath, it's actually doing the 2 requests in the Ethereum network. So that's a base. And the reason we did is basically easier ways to upgrade that when we want to add a new feature into the resolving mechanism. Prime example is now we not only resolve Ethereum address, we resolve 200 different coins. That didn't exist back in 2017 because there were 200 coins, right? Then when we added it, we can ask users to just switch the resolver to the new one, so you can do opt-in upgrade. And also, the resolver, we provide a default resolver, which does the basic thing, but you can actually write your own resolver that like any name you look up, it all goes to me or something like that. You can do it. And so that's the basic model. And what we are trying to present is called L2 gateway model, which is, it's not necessary for ENS, but we trying to make it kind of generic way that, for example, back in the day, everything was on-chain. But when NFT comes in, it kind of became a hybrid, right? Like one of the things people new to the Ethereum system get confused is like, is my NFT in the blockchain? No, it's just like a references exist. And all the metadata in smart contract, you have a reference as a URI function, which refers to. So that was a ERC 721 specific way of saying like, this is where you get off-chain data. We want to have more standard way of doing that. So I was supposed to put the link, but Nick Johnson recently created an EIP 3668, which I'm gonna tweet later, so you don't have to remember. And he created a name called Durin. I think this is Lord of the Ring. Are there Lord of the Rings fans? Lord of the Ring fan? What's Durin? Sorry, I couldn't hear. Sorry for asking. Yeah. I heard that that's some gate to some world. Okay, I don't know. Yeah, like he's into this fantasy all the stuff. He played D&D all the time, but anyway. I'm sorry asking that question. Sorry. I just confused myself. But during means some sort of a gateway. Hence, we wanted to generalize. We want to name is important. So we just said like, what name is important? Like these guys are all like geeks. So we all the geeks into Lord of the Rings. No one knows. So sorry for picking the wrong name. I keep typing Dorian, and then Nick is saying no D-U-R-I-N. I'm then type checking into Dorian, but. Probably we should call Dorian maybe, yeah. Yeah. Okay. Okay. Thank you. Digressed, sorry. But now I think people sticking to during, which is good. EIP 3668. So we defined, and he actually defined a kind of generic way, not just for ENS, that if you want to source data outside of layer 1, you should basically call the function, and that function returns an error type, which is a new, I think, basic construct of the Solidity. That when you do, before it was using revert and message, but now you can specify a generic type. So we suggested creating kind of, lookup something error, and if it returns, it looks into. Yeah, I'll explain what's the code, actually. Oh, no, I think that's the latest one. It's not in the code. But anyway, I think I keep confusing myself. But important thing is, rather than resolver returning the address directly, this during model return the gateway HTTP URL. And gateway is just a web services. Anyone can host. And you ask this gateway to go to fetch data from whatever the layer 2 or 3 or just your normal database. Give me the data back to it. But most of the layer like rollup model, they have a basic construct that they write their L2 state in I think core data periodically, and they each chain layer 2 When I say layer 2, I just infer that that's a rollups. Which doesn't include like state channel or anything. So just whenever I say layer 2, it's a rollup. Rollup has a ways to verify the state of L2 inside L1. So they just return the proof, data as a proof, and you write a resolver in L1, which verify that in L1. So like a gateway just get the data, and you just prove. And then once it's done, you're okay. So by doing that, all the Dapps integrate with ENS. You just keep like access into like ENS on layer 1, and then you never have to switch network as long as you are reading the ENS data. When it comes to updating, it's whole story. You have to switch. But majority of the case in ENS is like reading data is probably 90%, 90% of the daily use case. So we want to make the thing as easy as possible. So this is a design principle. And yes, I mentioned that there's a L2 gateway optimism demo, and there's a YouTube video. Nick is doing stuff. So if you're interested, there's a YouTube URL I'm gonna list. You watch like 5 times until you understand. But I will briefly go through the code or to explain what I try to say is that, yeah, can you read? Good. Yeah, so I think when you're in the L1 and you say in the contra, there's an address function. And instead of this address function returns data, it's doing the encoder with selector, optimism resolver stuff, which is creating this function signature as some sort of prefix with the gateway URL. And then the gateway goes to resolver on L2. And the resolver on L2 has whatever the way. This is just, again, as I mentioned, just a key value store. So it just returns. And then once it's done, so you have a, oops. Yeah, so before it was an address, but now you have an address with proof. And you pass the, I think, proof, which you got from the gateway. And here, this is a layer 2 specific code. And in this case, I'm very honest, I don't fully understand this code, but like this code does the optimism specific ways to verify the state root proof. And once it's verified, then it's kind of decoding the data from the state, and then you just return it. So this goes in 3 steps. That's kind of basic concept for how we're doing in layer 2. And in this way, yeah, you can update data on L2, but without compromising the security. You use the same security model for the L2, which is L1. So that's what we were kind of experimenting up until March, May, April. Then this happened. Well, it kind of started happening from February. That all the side chains actually took off. So this is a TVL on other EVM chains like Polygon and the BSC kind of, like competing each other. And we are, I think, maybe it's safe to say side chains and the EVM compatible. And then now there's like a, Nia, Celo, Avalanche. What other EVM chains? Moonbeam. Anything else? Phantom. There's so many chains, so we have to kind of think about it. So we've been brainstorming for last couple of months, and this is still at the design stage. So if there's any better way, we welcome your feedback. But like rather than creating the L2 gateway, we kind of came up with 3 different gateways. Bridge gateway, app gateway, trusted gateway. This one, I just named it like a couple days ago. So it's only in my head. So if you ask Nick, he might say, what's trusted gateway? But, so I use the same diagram. That instead of, so does anyone, so who has used Sidechain? Or like a Polygon, XDAI? Okay, so as part of it, you guys use a bridge, right? So, and I think it depends on the bridge. But you guys are aware that security model's bridge is different from the sidechain itself, right? So like sidechain, they might have validator or like whatever stuff. Bridge has its own unique sets of, I think some bridge says relayer, some bridge says like a verifier, that kind of stuff. But they have their own, its basic assumption is more like a multisig. That if you want to cross the asset from chain A to chain B, you lock the asset into this bridge contract, then it's locked and you mint in the other chain. So this one is actually your entry trust assumption, not necessarily this layer, the sidechain itself. So our kind of compromise idea is that, and it depends on the bridge, but I think easiest example is like XDAI. I think XDAI's sidechain is almost like a multisig of the relay of like 3 to 5 signers, and they sign, and if you get like 2 or 3 signatures, and then you kind of approve the transaction, and also their signer address is on L1. So what we are going to propose is like a gateway can get whatever way you could use graph or something and they get the data, and we ask these bridge relay, I call it, I think, operator. I'll call operator to unify the terminology, but bridge operator to sign this, the signature, just attest the signature says, yeah, this came from this chain, I'm bridging asset. And on the L1 resolver, as long as you can recover the address, and if it came from this set of signers, we'll just trust that. So rather than trusting the data, we just say we trust the bridge signer. So this could work in the sidechain model. And let me compare pros and cons. So pros is it kind of retains the same security assumption with bridge, not necessarily with a sidechain. But cons is we as an ENS, we can't do it because we are not the relay operator. So we have to ask bridge. So I was talking to some people who does a bridge, and yeah, they were saying, oh, so almost like bridge acting as oracle, which is really good analogy. So they do have all the same basic construct to do it, but what's missing is most of the bridge is based on the events. That when someone sends a transaction, they respond to the event, do something. So they don't really have the basic contract of just replying the random data whenever people ask. So they have to extend, which could be the blocker. So if we want to use this in a, like Polygon or XDAI or Phantom, I have to work with a bridge operator. So that's just a bit showstopper. So then we saw is like, okay, so if you are keen on, for example, have a Dapps in Polygon or something, rather and the bridge still doesn't support, why don't you, as a name owner, to sign message? What I mean is, instead of bridge to sign the signature, and the important thing if you refresh back is that you can set the gateway depending on the resolver, which is assigned to specific domain name. So matokun.is can have my own set gateway, and I can set up a gateway by myself, and I can have basically the private key or something of the address which is owner of the name, and I can host the gateway server, and I can sign the transaction, sign the request to say, yeah, this one I attest. In that case, you are actually trusting not even the gateway, bridge, but you are actually just trusting the person who set the domain name to trust. So that's kind of compromise. So now, yeah, verifying the name ownership, not data. So this is kind of next level. And if you compare pros and cons, yeah, so now you can stop on your own. Downside is you, as a name owner, has to host your own gateway. This could be okay or not. Like if you are like a game developer and if you want to issue subdomain to all your game users, this could be a good way. But yeah, cons is now like you're not even trusting the bridge. I can even trust further that if only thing you trust is yourself, do you even need a blockchain? So this is an ultimate, that's why I call it trusted gateway. Just put it in the database. It does it, right? Even like many NFT, like OpenSea puts into the database. So it depends on your user. But this one is the same way as app gateway, but you just use database. This is the easiest one. And let's just compare pros and cons. Is pros, no, Yeah, so you don't have to deploy ENS on registry. So one of the problem I didn't really discuss is like, okay, assuming you can point to ENS to some blockchain, then how do you know in L2, for example, Commerce says Commerce wants to, issue subdomains into L2 in Polygon. Oh, sorry, not L2, Polygon. They first has to claim that commerce.is is mine, claiming L1, but there's no ways to validate that in L1 and L2. So you have to do something special. But in this completely trusted thing, you just use your database, so you don't even need that. So this is the easiest ways to do. But downside is now there's nothing on sidechain. So one thing such as NFT, and the power of NFT is once it's tokenized, you can transfer freely. That can't be done, right? So that's a kind of cons. So if I sums up this kind of different trust model, so this is a kind of nirvana way we want to get to, but no one can get it soon. And also, again, we have to deploy the ENS into layer 2. We have to think about way of bridging the asset. So it takes a bit of time. So if you want to kind of experiment, you could actually go with this trusted gateway approach. And the good thing is that you can always upgrade to the different models, right? So you first do this and see if this model works. And when these are ready, you can kind of go to optimism, or you can do bridge gateway or up gateway. So that's kind of things we are thinking. And one benefit of this complete trusted one is that gas cost is completely free because it's not even on blockchain. And so how much time left? Anyone? Timekeeping? I think I talked 30 minutes. So
10 minutes, sir.
10 minutes, okay. So I'll go to FAQ. Then if you have a question, I can open it up to audience here. So back to the question, you mentioned the growth of the ENS goes up and down because of registration cost of .eth. But this one doesn't really solve the registration cost of ETH itself. It's more likely that it solves the cost of the update cost of the data. Like if you want to keep adding 100 different coins and stuff, the gas price is cheap because resolver is on layer 2 or sidechain. But Ethereum, .eth parent domains, resolver is still on L1, so it doesn't fix. And so I just answered. And registry contract will probably more likely to remain on L1 very long time. And you only move for resolver. So the ideal use case is, again, if you're the Dapps developers and if you want to issue subdomain cheaply, that's kind of the use case. For really solving the registration cost, we have to move the entire namespace. But good thing is that we can move per name. And if you want to exit to L1, you can also do that just by changing the resolver to non-gateway version. That's the first answer. And can I create subdomain on L2 and sell as an NFT? Yes, it can. So it depends on a feature called wildcard, which we haven't implemented yet, which we need to implement. But this is more of the front-end change that, for example, we do have request if you have 100 different different and we don't want to have a resolver and the hardcode logic there. So you could, the way we are thinking is that if if I have foo.matoken.is and the foo is not resolved, doesn't have anything, you ask the resolver of the parent domain, matoken.is, to resolve. And if this resolver is in L2, they can do whatever the logic. So this has to be implemented. But once it's done, subdomain may not exist in L1, but you can create subdomain in L2 and ask gateway to return. So in this way, it's possible. And and how do I, then last problem I touched upon is how do I, if commerce wants to go to Polygon or whatever the L2, how can I
have the ownership of the name on L2 when I only have the name ownership on L1, which is we are thinking about. So firstly, yeah, again, as I said, ENS is NFT. So we should be able to transfer the name to L2. And we could create a registry which allows you to mint names on L2 on the target chain only if your asset is done. So you have to do this kind of stuff. So it's possible, but like we have to build lots of things. And yeah, this is it. So we have the repository for L2 using Optimism gateway demo. And yeah, we have a discourse, and we can also have a discussion on Discord. And I think the takeaway is, yeah, so this is kind of where we are thinking. What we need the most right now is, so first part of how to do things on L2, we have a concrete idea, but the latter half is, it's still in a kind of idea stage, and I really need Dapps who's interested in issuing subdomains. And if you are going for, we want to solve the scaling per use cases. We don't want to create a solution which in a chain which no one wants to use. So if you have your favorite chain, and if you're thinking about deploying to the network, and if you want to use a use case of issuing subdomain to the user, I'd like to talk to you so that we can build a case on top of it. And also the app trusted gateway seems like a bit retarded, but like it's kind of pragmatic transition from just trying in a complete trusted way, then gradually integrate into trustless way. So I think, yeah, that one we want to build a case. So if you're interested, just talk to me. I think that's about it. 5 minutes left. Thank you very much. Maybe we have space for a couple of questions.
Yeah. Any questions?
No, that's good. Yeah, after the talk, you can just catch me anytime. Today, I'm wearing these T-shirts, so you can just easily find me. Okay, I think we're good.
Thank you.
Thank you.